So I'm Irosha Nawarathne, Associate Professor in Chemistry. You guys already have met me and we have talked a lot. So I'm happy to be here in Austin with Macmillan today and to talk about relevance and confidence, how it creates right chemistry between the learner and the teacher. That's kind of the theme of this talk. So just to explain you where Lyon College is located, it's in rural Arkansas, so it's primarily Caucasian population, and we have so many students who are coming from Arkansas itself, but we also have a lot of students who are coming from other states, including California, a lot of athletes too. And it's a selective liberal arts college. It's very small, you wouldn't believe. It's only about 800 students in total. But it's a very good school because we attract some of the best students from Arkansas and around just because of our reputation for being one of the best in the South, sort of thing. So in my talk, I will be talking about how relevance matter using some example activity. I have examples from the organic classroom because that's what I teach primarily, and I also teach introductory level chemistry as well as upper level chemistry. And finally, I'll kind of touch base on confidence, like how switching the roles between the learner and teacher helps me at least to improve the confidence in students. So speaking of relevance, I'm sure you all I have heard enough from you, so I think I already kind of know how you are and how good of educators you are, so we all agree probably that relevance does matter on what we teach and how we teach it, kind of thing. So relevance for learning and motivation in education, like all these different kind of literature shows us how relevance is important in learning and teaching. And one of the very interesting ones to me, the John M. Keller ARCS model is something that defines 4 major conditions: attention, relevance, confidence, and satisfaction. And he says they all have to be met for a student to, or anybody to stay and remain motivated in learning. So that's something I really care about, like this model, or rather like the information coming from that literature. This one is supposed to be highlighting the relevance, and then it is talking about meeting the personal needs, goals of the learner to effect a positive attitude. That's kind of the idea of the relevance. And then he has a lot of publications and studies done on relevance, how it matters. So when I'm not a teacher, and when I'm not doing pedagogical research, most of the time I spend doing undergraduate research. We have a really big group and doing very good in pharmaceutical discovery, and that's the example I'm going to bring in. So what we do is we use rifamycin Co, and then we modify it. So for example, this reaction, you're talking about naphthoquinone ring here, hydroxy group is changed to different groups, and then you further modify it using another chemistry to get extra triazoles and all that. And then in that case, you can create new modified rifamycins, and you can test them against bacteria because these are antibacterials, and technically you will have some that are useful, some that are not, and the statistics shows some are very useful ones and we can move on, some are not. And then now if I start, rather than showing that, if I started with what's antibiotic resistance, or rather it's one of the most urgent threats in public health, and then United States is going through like so many infections and death because of the antibiotic resistance, all that, if I keep going. And I can also show deadly bacteria, like all sort of deadly bacteria out there, and then especially the Mycobacterium tuberculosis, which is the second leading infectious killer after COVID-19, and top 13th cause, and all this information, and then move on to showing like the drug-resistant tuberculosis and how the financial toll goes through. For example, if you just have TB, to think about the treatment cost and everything per case, this is per patient, it's about 67,000, but when you go to multi-drug and extremely drug, your amount of money is very much, and that will be an overburden on the individual and the country and everything. So if I show all that and then make it a little more relevant, then now you are probably more interested in learning about rifamycins and how somebody can modify them, and then go on to that kind of research or talk about those reactions, things like that. So relevance does matter because it can come from the way something is taught. It could be the exact same information you are teaching them, but it's the way you teach it, like how you go from it and how you start it, how you introduce it, things like that. It does not have to come from the content itself. And then in general, those teachers who choose to instructional improvement project had made better progress and felt more positive. I definitely do. When teaching chemistry, one of the things over and over you hear is, oh, it's hard, like, oh, you teach chemistry, oh my gosh, like they think it's so hard. But then in fact, when you're teaching it, if you can show the students how chemistry is the central science and how applicable it is for your day-to-day life, it really makes a difference. And they wanted to learn more, they wanted to stay engaged, they wanted to actually do things and become better at it. Because even for a regular citizen, even if you have nothing to do with chemistry later on, learning chemistry would help you to be a better person or a better citizen. So some of the examples I'm going to show you from the pedagogical research in my organic chemistry classroom, because I'm organic chemist by training, and then also I teach organic chemistry 1 and 2 both classes, so I have the same students for a whole year, which is a great privilege. And I also teach the labs, so I get to know them really, really well. So when you're talking about it, I'm like, yeah, I'm always with them. And so you do get to know them very well. But regardless, teaching organic chemistry, one of the things in general people think is it's considered, or they have the perception of it's unduly challenging subject all the time, and also it's a gatekeeper for the science pipeline, especially in the health sciences. And that's because most of the students do not see a relevance, and what they do is the rote memorization, and then they will end up not being able to keep up and then not see a point of learning it, and then just doing it for the grades and then just lose it after some time. So in my case, when I'm making it more relevant and so fun to learn it, then they actually stay engaged. And one of the publications I had published in 2022, Alkenes Brought to You in Familiar Faces, and that's kind of the one I'm going to talk about in a minute. So alkenes are the first functional group, or the first group of molecules we talk about in organic chemistry sequence, and we talk about organic reactions afterwards with alkenes, things like that. So rather than teaching them this directly, what I do is I start with things they know, like pigments. Everybody knows this, and they know it's good for you to eat carrots, it's good for you to eat colorful fruits and vegetables, things like that, because people say so, it's antioxidants and all that. And most of these are organic, everything you're eating is organic chemicals. So basically beta carotene is in the carrots, and then if you're thinking about that kind of conjugated alkenes, then I can make the connection that how important these things to you everyday life, and then how much you understand does matter to your health, how you teach somebody else and how you perceive these things. So with that, it really helps. The alkene reactions, for example, if I just show them examples of basic reaction before I teach it, and then show them the ethanol is one of the example products you can make. And ethanol is the alcohol, people just say alcohol and drink it. So that one, you can kind of tell them, oh, well, this is something you know, this makes sense. So that one is showing where the answer is in fact alcohol. And in organic chemistry, this is so true, because for most of them it's very hard. So they do understand it, that kind of joke. But other than that, the polymers from the small alkenes, those ones also make all the plastics, and the polyethylenes, polypropylenes, all of them, they're all relevant. And then those are things you see everywhere, materials, food, everything. So organic chemistry is the chemistry of life and also the material. So basically it just shows, before I do this, I do a lot of assignments to get them interested in this, and then I teach them alkene chemistry and the reactions, and then that really makes a difference. So these ones I'm not taking extra time. These are mostly done as pre-lab assignments or the lab assignments in there. and they almost always like group activities and things like that. So they get together and then they brainstorm, they talk about things. So it's pretty cool for them and they love doing that kind of thing. And a lot of those you can do it at home with your cousins or, you know, like your siblings or even your children sometimes. We don't have a lot of non-traditional students, but if you are to, yeah, you can do it with children too. So they love doing that kind of thing too. So it shows how much they had the motivation increase by doing this kind of relevant material before they get to actual things. So I do that all the time, and this is just one. And as you know, we don't have time to write up all these manuscripts on everything we do. So this is one of the examples I'm showing, and there is another one. And that one kind of talks back to what Suzanne was talking about. So the whole time I'm thinking in there, and I'm thinking, yeah, so for some subjects, it's very straightforward to connect diversity, inclusion, things like that, because your material, or rather like your content in the class, kind of dive into it naturally. But in physical chemistry, it's hard to find that natural point of entry. In my case, what I did with students is, this was a while ago, but I published it only in 2019. So I've been doing that forever, to include diversity into my organic classroom and other chemistry classrooms. So what I did is I connected them, the social diversity and the molecular diversity. Because if you think about molecules, like I just said, everything is chemicals. There is nothing you can try. You can't name something that's not chemical. So by introducing that and showing them how important it is to have so much diversity in chemistry, that would make this life, that would make this whole world and everything, really help them to think about social diversity. So all I said is probably just what I just said. Like I would go to a class and then talk about that, and then give them the assignment to connect social diversity with molecular diversity. And then they did a whole lot of different ways of coming and showing, like assignment wise, what kind of feedback they're doing. So they made images like showing how carbon is connected or bonded to other atoms. That way it is really giving the diversity of molecules, because if it's just carbon, then you will be talking about the lead in the pencil sort of thing, or it could be the graphite, and then graphene or graphite, and then also diamonds and things like that, very basic things. But if you want to move on, you have to bond carbon with other atoms or elements. So those the kind of things they showed as images. So some of them even wrote books on it, like they actually literally wrote books on it. I'm only showing you a few of the examples from the publication, the other ones in the supporting info. So they went above and beyond doing things. Some of them even sew material, like they actually brought like a physical material. So all of them are published, so you can go back and look at them if any of you care to do it. Some of them did not connect social diversity and molecular diversity very well, but they were thinking about DEI or diversity in the sense of doing it and during the activity, which helped them to really connect to the class and then become inclusive classroom and all that too. They were really connected. And then this was, both of them were combined and then published with Research Outreach. They did a little article on it. So if you guys ever care to, I guess you can go ahead and look at both those things together. Making chemistry or organic chemistry fun and meaningful and accessible was what they were talking about. So that was part of relevance. And then if you think about confidence, confidence is saying the helping the learners believe or feel that they will succeed and control their success is at least what the Keller says confidence is. And in my case, I think it's so important because chemistry is a hard subject. And most students lose the confidence that they can do it, especially in the introductory classes, because every other year I have the opportunity to, I have a free up space in the teaching assignments that I can teach introductory class. I love teaching it, but I rarely get a chance to teach it. So when I do that, it's usually like 45 students or so, which is a large class in Lyon College, at Lyon College. And those students are not prepared. They are generally low math skills and even regular study skills are very low for them. So you have to keep them motivated and confident too. So in my case, there are so many things I do in introductory class as well as the organic chemistry, because organic chemistry, yes, it's an upper level like second or third year class, usually a sophomore year. But regardless, it's an introductory organic chemistry class. So even there, you're learning for the first time organic chemistry, like pretty much teaching a language, like new language. So in an introductory class, I think it's very important to make them confident, so they wanted to not fail the class, not do anything, just wanted to keep going and then be able to be successful. One thing I definitely say I do a lot is switching roles in the classroom to improve confidence, because if you change the role, learner and the teacher, definitely students feel a lot more confident. Now they'll be in the power and they'll be the ones deciding what they wanted to do with the class or the lab, or they might be the ones who are teaching other person, because we all know no matter how we can argue about it, definitely students, no matter how trained we are, they learn more from each other than they can learn from us. So those are the things I do. If you keep going, you can see some of the examples would be, I do 5-minute cheat sheets before an exam in introductory class. These are wild classes. You can't even imagine. Those students are like majority of them. So most of the time I have like the whole football team in that class. So they're wild and crazy, but at the same time, when you give them the 5 minutes, you don't tell them. They come prepared to take exam, and then you're like, okay, take 5 minutes and write whatever the cheat sheet you want to make, do it. They go so quiet and they're so interested in it, and that's the time they actually put their brain into it. And I think most of them tell me they never looked at the cheat sheet during the exam, but that gives them the confidence, oh, I can do it. So those are things you can totally do. And then pair up quizzes. A lot of times in introductory classes, I do paired quizzes rather than, I give them time individually to do it, maybe like 5 or 10 minutes. And then I say, okay, you can go to the next person, and then you can do it together, and then that's what I'm grading. And that really helps them to believe that, oh, I can, and I can learn from someone. And then doing group activities really help me, that kind of things too. So active learning type of questions are what I usually use in the beginning, but then I also do it for other activities too. Group exams in organic and upper level classes have always helped. Those are real exams, but they're done in teams, like 2 or 3 people. And those exams also have been very fun. And it's not like that's the only thing I do. These are just additional to the regular exams, regular quizzes, things like that. But it really helps them to not go to DFWs. They stay motivated throughout the semester. And majority of the introductory students tell me, the very low skilled students, they tell me, this is the hardest class I'm taking, and this is probably the most I ever learned in my whole life, but this is also the class I'm performing the best. And that means something. And then also provost sometimes email me or call me and ask, or whenever we meet, he would say, how do you keep up with them? Because this student fails everything, and then he says in chemistry, which is the hardest class. And I guess that really makes a difference, right? So comprehension and critical understanding of advanced technical articles or report writing, things like that are very hard in organic chemistry, you guys. So if you're a historian or someone else like not really into science, I'm sure seeing all those molecules doesn't make you very happy. So they can be very technical, and students find it the same way. So making them to be able to get there, if you can do group activities, that really always help. And most of these things, I have the privilege to use my lab time to do that kind of activities, so I have extra time, of course. So what we do is the 21 game. If anybody want to ask questions, I can go over it. We could use it for an advanced question, like organic synthesis is what I usually use it, or sometimes applications of chemical instrumentation and things in upper level classes. So what you do is you write your own answer in an answer, like a little sheet I provide them, note card, and then they exchange it, and then they grade each other's stuff. So you learn in every round, you will be learning new answers and how you think about rating those answers, all those things, and by the end of it, they're really thorough with what they're trying to do. Because those questions have to have multiple answers available. Like if you're doing that kind of work, you have to have not just one straightforward answer, there has to be many ways to do it. So these are some of the questions I use in, very few questions I use in instrumental analysis class, upper level class. So they can have, I can post the question and then they'll read it and then they'll be writing their very short answer, but it has to be a thorough answer if they want to get good grades. So they write it and then they exchange it and then others will grade it for them, and then technically they get a grade based on participation, but still they do very well because they don't want somebody to see their very rude, not so good answer. So they try hard and then they take their time to do it too. So project-based learning is the last one I'm going to talk about. So here how I improve the confidence is by giving the student the role to lead the class. So basically, rather than, I think I have heard a lot of people say in many different conferences, they let their student decide what they want to learn as they go through the syllabus. I do the same. Like I have a syllabus and it says tentative schedule, but then I change it lot of times because the way students perceive it, and then if they really care to learn something else, I can change it too. So similarly here, especially in the labs, I let them pick their own lab projects and then do studies on them, and then that makes them to pick something that's meaningful to them, and then some of them have gone into doing actual long-term research projects based on students' idea that carried away during the semester, then they continue it. And 4 of the examples I have shown here. One is the microplastic analysis in food and water. The another one was the artificial sugar sucralose or Splenda, and heavy metal presence on campus water resources. This actually got to very interesting results, like talking to the administration too afterwards. And then caffeine and other pharmaceuticals in natural water resources in Arkansas. We have so much water in Arkansas, so looking at those things too. And this is the microplastic project, and we are about to publish that one in fact, but it started as students. I gave them some ideas, but then they're the ones who actually designed the whole project and they work on it during the semester, and then they work through it to figure out later on. So most of them ended up coming during the summer, doing research with me on the same project, or continued even after the next year to do research project on it. And then another one is the modified sucralose synthesis, because Splenda, most of you probably use it, I never do, because that one has a lot of effect on gut bacteria. So students, when they get to know that, they were wanting to do research on developing antibacterials based on the structure of sucralose. And we also have pretty interesting results on that as a research project later on. And I think that's really like the conclusions would be how relevance is improved. I use familiar examples in organic chemistry and other classes, and then create inclusive learning environment by doing diversity activities and things. And how confidence is improved, I would say project-based learning and peer-based learning. However, in each case, you are switching the role with the learner and the teacher.